Hello guys, I am Bhaskar and you are welcome to my channel. So this time I am bringing to you a new machine learning project, that is how can you determine Parkinson's disease through machine learning algorithms. And this time I am using dimensionality reduction technique to increase the accuracy of our models. So stick to the video till the last to learn the new technique. And you can download the dataset from the link that I have added in the description. So let's get started. So first we will set our directory to that folder where our dataset is located. Yes, this is Parkinson's folder. Then okay. Now we will first import our libraries. Okay, importing the libraries. Now importing numpy as np, and then import pandas as pd, and then import matplotlib.pyplot as plt. Now we will run them first. Okay, importing is done, and then we will import our dataset. Commenting out, importing the dataset. This commenting of the code along the written code is very important. It describes what is actually doing it. So getting a habit of commenting out is very good. So you should keep it. So dataset we will use like pandas library, pd.read.csv, parkinsons.csv. Okay, now let's run. Okay, in the variable explorer we'll get, yes, this is the dataset. Okay, this contains the various features about the cell and also about the status, and it is Parkinson's positive or Parkinson's negative. Now we will divide our dataset into the independent set and the dependent set, and now X dataset will contain the various features on which the results depends on. From we will take 1 column 2 to 9 10 11 12, then 13, oh no, 13, then 14, 15, 16, then 18, 19, 20, 22, 23. Yes, done. And now we'll set our y set. This will contain the 17th number column, which contains the results, that is whether the cell ID is Parkinson's positive or the negative. 17. Okay, yes, we have to write dot values here and now there, dot values. Okay, now let's run. Okay, now okay, let's say x, so accept, this is the various features on which the results depends on. Now on y set the various results. Now we will split our dataset into test set and train set. For this we will use the sklearn dot model selection. From there we will import train test split. Yes, now we will write the various splits: x train, x test, y train, and y test. Now we will copy this one and paste it below. Okay, now we will set the various hyperparameters like the test size, like the different sets from where the splits will be taken. We will keep the test size equal to 0.2, which means that 80% of the data will go to the train set and the remaining 20% will go to the test set, and we will keep the random state to 0. Okay, now let's run. X train, X test, Y test, Y train, Y test. Okay, now let's feature scale our data. Feature scaling is important, as we have seen that our data is not have regular values. These are various irregular values are there. So it's important to feature scale our data so that it does not create problem for our machine learning model to fit, as machine learning models uses the Euclidean distance to plot various distances and calculate the results. So now we will use here sklearn.preprocessing, and we will import standard scalar. Yes, then we will objectify it, then standard scalar. Yes, strain is equal to scx dot fit transform. We will fit transform our train set, and x test we will just transform it. Okay, cx dot transform. Okay, now let's run it. Okay. Oh yes, I have missed one bracket in the standard scalar. Okay, now let's rerun again. Okay, now it's done. Okay, now you can see it is properly scaled. Okay, now comes the most important part of this video, that is, now we are going to use our dimensionality reduction technique. In this technique we are going to remove those features which are contributing very less towards the results. First of all, we will see the various factors and their amount of contributions, and then we will select only those factors which are contributing more. That is, this is the type of feature extraction technique which is called principal component analysis. So we are going to use from sklearn.preprocessing import PCA. Now first we will set our n components to none, and then we will fit transform our x train. X train equal to PCA dot fit transform x train, and x test equal to PCA dot transform. From X test. Okay, now we will see the variance report. That is, we will see the various factors. That is, we will see the list of factors and their contributions. We can say that. We can say like that. PCA dot explained variance slash ratio. Now let's run. Okay, I've made a mistake here. That is, it should be, and from the scale learn dot decomposition, it should be decomposition. And now let's run again. Okay, now let's see our variance report. We can see that the top two features, the 0 and 1 feature, is more contributing, so we can choose them. That is, top two features we can write 2, and now we have to rerun our code again. And let's run. Okay, done. And now we can see that our X train set reduces to only 2 features. Our X test goes to only 2 features. And now our data is ready to be fitted in the model. Okay. Okay, let's start with KNN model. From sklearn dot neighbors, we will import K neighbor classifier. Okay, now classify will be is equal to K neighbor classifier. We'll set the various hyperparameters. We'll set n neighbors equal to 8, and the values of the hyperparameters I have set after seeing various numbers. So you can check by changing these values, so you can get to know how I got these numbers. And now you can see, now we will fit our data X train and Y train. Now let's write the code for predicting our results. Y1 pred is equal to classify dot predict X test. Okay, now let's run. Okay, there is a spelling mistake there. It should be Minkowski, K-O-W. Yes, now it will be okay. Now let's run. Okay, it's done. Now let's see the results. Okay, Y1 pred. Okay, these are the predicted results. Okay, now let's check our accuracy. From sklearn we will use dot matrix, will import accuracy score. Accuracy score equal to, now we will set the first real results and then the predicted results. It is y test comma y1 pred. Now let's run. Okay, our accuracy comes to be 94%, 94.87. Okay, now let's fit our data to the next model. That is fitting the model in the SVM, support vector machines. Now from sklearn.svm we will import svc. We'll objectify it. So class classify2 is equal to svc. So now we will fit classify2 dot fit xtrain comma xtest. Oh sorry, xtrain comma ytrain, and then we'll write the code for results y2 pred classifier classify2 dot predict xtest. We'll run the code. Okay, fitting is done. Now let's predict our results. Okay, prediction is done. Then these are the results. Okay, now let's check the accuracy. We will simply copy the code the above, okay, and paste it below. We will simply change the y1 pred to y2 pred. Okay, now let's check. Okay, it's slightly decreasing, 92%. Okay, now let's fit our model, fit our data into the next model. That is, we will fit our model into random forest classifier. And from sklearn dot ensemble will import random forest classifier, and now we will set this as a class. Classified tree is equal to random forest is equal to, copy and paste it below random forest classifier, and we'll set the hyperparameters and estimators, that is the number of trees. We will set it to 16, and criterion to entropy, and this number of trees I have got after testing it many times, so you can check it, check yourself how the results vary. You can by changing the number of trees, so you can get it random state to equal to 0, classify tree dot fit. x train, y train. And at the same time we will write a code for checking the results. Y tree pred equal to classify tree dot predict x test. Okay, now let's run the code. Okay, fitting is done. Y tree pred. Okay, let's see the results. Okay, result. Okay, these are the various predictions. Okay, now let's check the accuracy. So we will simply just copy the code as usual and paste it below. We'll just slightly change this y2 pred to y3 pred. Okay, now let's check the accuracy. Okay, it gives 97%, 97.4. It means this is the best model from the remaining two. So okay, then now let's check this the incorrect predictions by our model. Okay, for this we will bring in the confusion matrix. Okay, simply we will import over the accuracy one. Simply we will put a comma and write confusion matrix. Yes, and cm equal to confusion matrix and y test and y3 pred. Okay, now let's import it. Okay, now let's see the confusion matrix. Okay, where is cm? Yes, there it is. Okay, we can see that the model only predicted only one incorrect prediction. So this model is the best model among the three. I have only tested this model only through these three machine learning models. You can try on your own the more models. So here it comes the end of this machine learning project. So, and I'm coming with more machine learning end-to-end project. So stay tuned, and till then, take care.